Now understand this question. The number of 5-digit numbers which are divisible by 3 that can be formed using the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 when repetition of the digits is allowed. This is more important for us. And the 5-digit number must be divisible by 3 and the number must be a 5-digit number. Now let's understand this. When we wanted to form a 5-digit number, there will be say 5 positions. Let's call them units, tens, hundreds, thousands and 10,000s. Now as 0 is not among the choices, we can start arranging any one side, right? Let's begin the arrangement with the 10,000s place. Let's not worry about the divisibility rule by 3. We will come back to the number whether it is divisible by 3 or not at the later stage. First, the 10,000 position can be arranged in how many ways? Yes, this can be arranged in 9 ways. We can use any one of the 9 choices possible. Now once we arrange the 10,000s place, what are the choices for thousands place? Yes, the thousands position can be arranged because repetition is allowed. This can again be arranged in 9 ways, right? Now again, the hundreds position can be arranged. Yes, because repetition is allowed. This can again be arranged in 9 ways. And the tens position can be arranged in, because repetition is allowed, 9 ways. Now after this I am not arranging the units position. The units position will be arranged so that the final number is divisible by 3, right? Now when is a final number divisible by 3? Provided the sum of the digits is divisible by 3. So till now that we have arranged 4 of the positions, we will find the sum of the digits up to these 4 positions, right? The sum obtained at these 4 positions will decide which number to be placed at the units position. Then the sum of the digits in 10,000s, thousands, hundreds and units place will be either in the form 3n, one case, or it would be in the form 3n plus 1 or in the form 3n plus 2, right? The sum might be directly divisible by 3 or it could be in the form 3n plus 1, that which leaves a remainder 1 up to the 4 positions, or it should be in the form 3n plus 2 which leaves a remainder 2 when we add the digits which we used up to the 4 positions. Now in case if the sum of the digits in the 4 places in the 3n form, then what are the choices that can be filled at the units place? Yes, because already the sum of the 4 places is a multiple of 3. Then the units place also must be that number which when added to the 4 should give us a multiple of 3. This is possible only if use either 3 or 6 or 9 in them, right? So that place can be 3 ways. Now similarly, when the sum of the numbers instead of 3n is only 3n plus 1, that means up to adding these numbers which are in the 4 positions, it is leaving us a remainder 1. Then in order to make the final number to be divisible by 3, this units place must be arranged with a number which compensates the remainder. That means this is possible only provided we use either 2 or 5 or 8 in the units place. This can also be done in 3 ways. Getting it? Now similarly, if the sum of the 4 numbers is in the form 3n plus 2 which leaves us a remainder 2 by dividing by 3, then this remainder 2 must be compensated by the number which we place at the units place. So only 1, 4 and 7 will be coming at the units place. This can also be done in 3 ways, right? And remember, after we arrange the 4 positions, either the sum will be in this form or in this form or in this form. That means only one such thing will happen. So using this observation here, shall we conclude the units position now can be arranged in how many ways? Yes, only 3 ways, because either this case or this case or this case, there will be only 3 such possibilities will be there in any of the case. Therefore, by fundamental principle, the total required arrangements will be equal to positioning of the 10,000s place in 9 ways, and the position of thousands place in 9 ways, and the positioning of hundreds place in 9 ways, and the positioning of tens place in 9 ways, and the positioning of units place in 3 ways, which is same as writing 3 square into 3 square into 3 square into 3 square into 3, which is 3 to the power of 9. If you observe the options, the option presented A is same as 3 to the power of 9. right? It's nice application of divisibility rule of 3 and forming a 5-digit number. First we arrange only the 4 positions and then we'll see the required possible arrangements of the last position. Now this problem became so simple to calculate because we have not included 0 in this case. But I suggest you can practice a problem where 0 is also one of the choice. Then the arrangement cannot be done so comfortably, right? You can practice such a problem for your own practicing, right?